Hello, everybody.
Hi, Professor.
Hi. How are you guys doing? How's the week?
Busy.
Yeah, I know. Just school just started. The first couple of weeks, you guys need to adjust your schedule and everything to accommodate. All right. Okay. I had a rough day too. Pretty busy. Anyway, everybody can see my screen, and if everything's okay, I guess we shall begin. Can I get some response in chat? Thank you, guys. Thank you very much. By the way, do you guys have SolidWorks ready? Or you guys running into any problem? Any feedbacks on SolidWorks?
I'm good.
Okay. So anybody who have problem? And if not, let's begin in like 10 seconds. Yeah, I will. Okay. For the recording, I'm gonna record all three classes, but I think I'm just gonna upload one because all three classes are most likely identical. So I have the recording from Tuesdays, and the Tuesday. So pretty much, I'm gonna record all three, right? And then at the end of Thursday, I'm gonna do a comparison. Like, definitely upload the shortest one because all the materials are covered the same. So I think I'm gonna upload at Friday, maybe Friday night. Definitely, I'll get it ready before weekend. So if you guys want to see it, watch it again or something during the weekend, you definitely can do it. And the homework, I post a homework one on Blackboard. It's a mix and match, very easy exercise. I set up the time for 3 weeks. So theoretically, it's due next Wednesday. But we have 2 weeks delay policy, right? So that total length is 3 weeks. You guys can just submit it anytime with your answer. However, I'm gonna post a solution next week. So if you really want to test yourself, see how accurate you get, do it before next week. And I think that's about it, right? Okay, let's begin our PowerPoint. This is something I want to go over on the first week, but the first week, people are adding. We don't want to go anything in detail. So let's talk about this today. And after this, we're going to do some simple modeling in SolidWorks to demonstrate how you guys can start making a very simple part. And that shall be all today's content. All right. I'm gonna display this, so I won't be able to see chat because I'll have one monitor, unfortunately. So if you guys have any questions, want to ask, just ask in audio. Just stop me anytime. Okay.
Sure thing.
Cool. Let's begin. All right, you guys can see it, right? Pretty much the cover page. And let's go. Introduction. So in front of you is the engine block assembly made by SolidWorks. And you can see it's somehow detailed, but not so detailed. It's just very simple one. And it's the animation. I'm gonna play it. Here we go. So now you see it's a cross-sectional view of how an engine running. You see the cam, the piston, and everything just it should be. So let's quit from here really quick because I want to see your response in chat. Our term project, I want to talk about it now. Our turn project, you guys gonna make an assembly very similar to this. However, I'm not gonna restrict you to just make an engine block because I know like not all of you guys are car guys, so some of you doesn't even know how engine runs, right? So how many of you guys want to make an engine block as your final project, which weighs 40% of your total grade? Please type in chat anybody who wants to do something like this. A 4-piston, 6-piston VA, or if you want to go fancy, W12, whatever. RB25. Alrighty, cool.
RV25 would be cool.
Yes, I know. Good. So yeah, anything like this. So I'm requiring not so much detail. You can see like the body is a rectangular box, right? Definitely not an engine shape. Okay, I'm not gonna ask for too much of detail, okay? But this whole assembly should be successfully running. It's optional for you to generate an animation like this or not. I mean, it's not required, but when I opened up the assembly, I want to see everything mating together, no penetration, not falling apart, and is running as a mechanism, you know. Do you guys okay with that? And for those of you guys don't want to do engine block, you guys can do something else. For example, you have a bicycle and you want to make a bicycle on SolidWorks, very simple and straightforward, right? And you can go ahead and do that, but making sure all the ratios and all the mating components are functional, I'll say, and be reliable. Or you want to make like a music box or anything, maybe a watch, like a simple geared watch, not having like 50 gears, but simple enough, or an elevator with pulley system, stuff like that. You can definitely do that. I will go over the detail on probably the 4th week, because that week we're gonna settle down with all the details for the final project. But today I just want to give you a heads up, like what are you expecting for your 40% of the grade. So my grade gonna be very loose on that 40%. If I see this assembly is running, is making sense, is not something it's not something very simple. For example, if you make a vise, like 2 or 3 parts and fixed on a table, definitely that's not a good assembly I wanted. Right? I want a mechanism. I want something that can run and function. But I will go over details, like for example, how many parts minimum, and fasteners included, and which part I want to see a drawing, which part I don't. I will let you know on the 4th week. Okay, but this is a pretty good example. Like if you submitted something like this, like an engine block, you got an A for sure. I'm telling you that. All right. Any questions or no? We're gonna continue. All right, let's go. So drawings is a very big part of this class too, because your first project is a drawing, right? First projects, I'm probably not gonna check your model. You can do whatever the way you like, but the drawings I'm gonna be very focused on. And you guys can see my mouse, right? When I point at some dimensions, you guys can see it, right?
Yep.
Okay, good. This is a hub or is flange, whatever you can call it. And you see right here, this view, the isometric view is the standard view, give you an overall look like for this part. So this view doesn't really important. It just give you a concept like this part should look like, because sometimes things are hard to visualize. So this one is definitely optional on drawing. You're nice to provide it for the people who doesn't know what are you making. And right here at the bottom the right hand corner called title block. Here contains all the information that's written for this drawing. Like it's kind of like its property table. And this drawing doesn't have a note. A note should always appear at your top right hand corner. And notes can be like the first one, I want the surface finish to be certain roughness, or I want this part to machined and weld and the machine again, something like that. Anything you want to add to the manufacturing process could be a note. Normally should be appear right here, but this one is too simple. It doesn't have any note. And the three drawings, they are projection of each other. For this one, you can call it front view or top view. It seems like we're gonna call it top view, right? We're gonna view it from the top. And this one shows the flange itself. And the front view right here, you can see there's a bore and you can see 3 holes and they're all dashed lines because you cannot see it from the outside surface. Right? If you imagine this in your brain, like the holes and the bores are all covered up. That's why I need dashed line to represent its existence. And this one, we can call it a right view, but it's more cross-sectional. You can see it's section AA. And section AA, you can look at the top view. There's also an AA. That means this cross-sectional view is generated by this boundary line. This boundary line is kind of like an invisible knife, cut this part into in half. And the arrow pointing part is whatever is showing this image right here. So since this is a symmetric flange or hub, the two halves are pretty much identical. So this one doesn't really matter. But if you have like something not symmetrical, you're gonna look different. So flip the arrow to display the part which you want in which direction. This is the detail view. This detail view says detail B. And detail B confined right here. This is one way to express a detailed view on certain drawing. Another way is you're gonna have like a detail B and a leader point to this circle. That's another way to express it. That's my company use that. Like we don't normally use 2 arrows pointing at a B because it's gonna cause some confusion. Okay. So now you guys can see this 5 views of one part. And let's go over dimensions. Dimensions, the most significant part you can see is not all the dimensions have the same sig figs or decimal places, right? The thickness or the diameter, you see the thickness has no symbol in front of them, none of that. But diameters, they're gonna have a geometric symbol right here called, it means diameter. And thickness, diameters, or even hole diameter and the center distance from 2 holes, they're all 2 sig figs. Sorry, not 2 decimal places. The reason why is that these are 2 decimal places, and this one, the center bore, is 3 decimal places, is when you look at your title block. Right here, this section, it says default tolerances. What does default tolerances mean? That means on your drawing, sometimes a complex drawing will contain maybe like 50 dimensions. You won't, it's not necessarily to generate all the tolerance on each dimension. They're gonna cost you a lot of time, and sometimes it's easier to make a mistake, right? The more you do, the more likely you can make a mistake. So some simple dimension, like non-critical dimension, something we care less than the important one, we can include those into default tolerance. For example, the thickness of this this flange right here. Does it matter? Yes, it matters. But if I'm making a 0.76 thickness instead of 0.75, what is the worst thing it can cause? The worst thing is your screw is not long enough, right? You're losing engagement. But normally, when you're picking a screw, we always pick a quarter or even ½ inch more than it needs to be, because we gotta calculate the thickness of the nut, and we also want the screw, the tip, the tail of the screw extrude out of the nut. Therefore, there's no cavity, there's no corrosion effect inside of the nut. So therefore, a 0.01 length difference on thickness not going to affect your assembly at all, because your screw have another quarter more room to wait for you, right?
Just a question. What's the fillet? How do you know how big the fillet is on the sides?
A fillet?
The fillet? Yeah. Is there a fillet? Oh.
Yes, this is a fillet. The 0.08 right here is a fillet.
0.08. Oh, okay.
Yeah.
Thanks.
Yeah, no problem. So the thickness, we can leave 2 decimal places, and we can look at right here. Right here, it says plus minus 0.1 for 1 decimal place, plus minus 0.030 for 2 decimal places, plus minus 0.005 for 3 decimal places, and plus minus 2 for angles. What does this mean? That means if you have a 0.75 tolerance, you come here, it's 2 decimal places, right? Your tolerance for this dimension is plus minus 0.030. And that's, if it's in inch, that's 30 thousandths of inch, and we call it 30 thou. Okay, and same to the others, and even to the diametrical dimension, they will have this 30 thou as their tolerance. However, the bore, you see here, the bore have 3 decimal places. Why? Because the bore is gonna run through a shaft. You never want to mess up your shaft if you're dealing with rotating equipment. When your shaft get damaged, the entire thing gotta shut down, and you gotta order a new shaft and wait for the new shaft shift and replace the shaft. So that's tremendous loss to your operation. Therefore, if it's bore dealing with rotating, no matter is lubricated or not, it definitely should have a tighter tolerance than the other dimensions, for example, the thickness. Therefore, it has three decimal places. However, this time we're not going to the default tolerances because it has its own specific tolerance at the right-hand corner. You see the plus 3 thou and minus 0. Why we labeled it? Because it's different than the 5 thou right here. It's even tighter than the default one. Therefore, we need to specifically label it right on the dimension, making sure the machine is not messed up your product. So this bore, the largest can go to 1.503, and the least, it has to be 1.5. Okay, that's the tolerance. And the hole, 4 holes, 4 times a ½ inch hole, and that's 4 holes, right? The reason we label that is sometimes when you guys deal with drawings, the drawings is not drawing is sometimes not always reflecting the true model. Depends on like your layer setting and your model importing stuff. Sometimes you miss the hole right here. But if you label it clearly about 4 holes and the machinists see there's missing a hole, they're gonna let you know. Instead of just going through with 3 holes, and when you receive your part, you missing a hole, that's that's not fun. So clearly stated, sometimes you're gonna have a more no, like drill through or tap through or to certain depth, something like that. Depends on what kind of screw you're using. But seems like this one is a through hole, 4 times ½ inch through hole. And the detail view, just to show the chamfer. And sometimes the chamfers are not showing because we don't care about the chamfer. And we're gonna put up another section right here saying, please break all sharp edges and corners. They're gonna apply chamfer or fillet, whatever they think is cheaper to do and easier to do. But this time, maybe it's gonna run, maybe it's gonna attach to a sealing surface. So an O-ring might be fitting there or something. They want a specified chamfer, which is 0.08 times 45 degree. Okay, so that's just one way to display the chamfer right here. And and the scale 2:1, because you see this one is definitely bigger. It's zoomed in, right? So it's 2 times than this one right here. Okay, any questions? Okay, today we're gonna do model demonstration, and next week we're gonna do drawing demonstration. So next week I'm gonna make a drawing like this in front of you guys. Multi-view and pictorial views, like we just explained, lines, different lines, solid line, dashed line, and multi-views. There are front view, top view, right view, detail view, and pictorial views. You don't have to memorize the terminology. You just make sure you can understand those. And when you discuss with other people, you know the right way to say it. So edge line. So those are boundary lines. Pretty dark, obvious. And primarily using most drawing, using all views drawing, the engineering drawing. Yep. Hidden lines, something you can't see from the surface, but it does exist within the part. So we use dash line to demonstrate that, so that whoever the machinist working on this part knows exactly what they're doing. And for example, this is also a dashed line, but normally we call it as a dashed axis. Any through hole, or actually any hole or circular, how's it, circular extrusion cut or something like that, you need to have an axis. So that means it's a hole. Yeah, you can see the cross-sectional view, the bore, and the 2 holes displaying right here, they all having those axes. And even the isometric view is optional to put those axes through the hole. But definitely these kind of drawings, you need to put these axes right here. This is not strictly required, but this is really good practice, because pretty much the machinists know what they're doing, and there's a hole, they definitely know it, and it's really unlikely to miss it without those axes. Yeah. Oh, center lines. Yeah, center lines. Better term. Yeah, I'll keep that term. Okay, pretty much this is a summary for multi-views. Nothing much you need to memorize, but do understand orthographic, parallel, projection, all these terms. So, when you're making a drawing, talking to anybody, they know exactly which part you're talking about. Okay, this is another animation of a very simple part. Let's watch it. Does it? Okay, so This is just showing you how parts are oriented and how the drawings are made based on this part, right? Because when making the part is always probably a isometric view or perpendicular to one plane. But this one demonstrates you how the drawing function implement the part into a 2D platform. This one as well, parallel versus perspective. It is, one looking like this, one looking like that. We'll deal with some structure. They want two set of views. So, like for example, in FEA, if you guys know what FEA is, the vibration stimulation. They always want like bi-direction because they want to see how the deformation is per direction. This one is like looking at the front. This one is looking from the side. You see, same subject, different result because a different way you look at it, And this one pretty much is explain about the animation we just watched. It's gonna be an L shape from left side. It's gonna be a somehow echelon form from front side. And the top side is gonna just be like a shackle or something. Oh, and by the way, this one, the line in the center is solid because it's representing an edge. You can see the model. So any edge should be displayed on the model. I don't know if SolidWorks have this problem. Sometimes Creo does this problem, like when you're making a part, one of the edge line is disappeared on your drawing. Don't know why, but you need to manually enhance the edge view, the edge line on the model so that your drawing gonna look exactly as you want it. Maybe SolidWorks doesn't have that problem, but it's just a heads up. Like if you're making a drawing, a top view of this part, and the center, this line in the middle somehow disappeared, you need to manually add it back. It is important. Okay, a 3D display for this part, and you're gonna get like this when you actually make this part a drawing through projections. And this is just with caption, top, bottom. Oh, you can see the bottom is different than the top. Why? Because those edges, you're not seeing those anymore, right? If you look at the part from the bottom, you're just gonna see a plain surface with like a shackle shaped. I don't know how to describe it, but anyway. So those are dashed line because the edges do exist. It just doesn't show from the bottom. And this one shows you how pretty much is from 2 slides before how this part are made, because you see it from this side, I see it from this side, and this one it just exact projection. Okay, perspective projections. Well, this terminology, I'm gonna post this PowerPoint online, and you are welcome to check it and remember memorize this terminology if you like. But these are not gonna be on the quiz. I mean, this is a modeling class, right? Not English class. I don't require you guys to remember any definition as long as you know what you guys doing. So read it, isometric, dimetric, and trimetric stuff dealing with coordinate systems. Isometric. Okay, guess that's all the PowerPoint. Any questions?
Yeah, I had a question.
Sure.
Is shading like important when it comes down to modeling in 3D?
You mean shading or like wireframe, like those kind of display?
Yeah, like you know how like some parts are darker and some parts are lighter.
Mhm.
Is SolidWorks already going to automatically like already apply shading, or do we have to like
Yeah,
do it?
it has a very basic standard of the shading. Like for example, the front side of this part look a little bit darker than the top side. Yeah, they're gonna automatically do this. But the shading, if you're dealing with rendering issue, like for example, you're making a presentation and you want to make your part look outstanding. Like for example, I want my screw and nuts in different color. Yes, you can do that, but it's not required by by this class how to model or how to draw. So I would say shading is not a problem. Like to me, shading is not a problem at all because we're presenting the 2D drawing all the time. The 3D modeling is just a step to make a 2D drawing. I believe once you get in the industry, when dealing with the manufacturing, they focus on drawing way more than your model. But if you're running simulation, for example, FEA or other stuff like thermostatic simulation, whatever, your model do matter, but the shading, the coloring doesn't.
Okay, thank you.
Yeah, no problem. Any more questions? Okay, I guess everybody's good. If you guys want to ask more about it, then after next part. So let's do SolidWorks. Today we're gonna do two very simple parts, just to give you guys some heads up to how to start using this software. And next week we're gonna do drawing, and the further on we're gonna do more detailed and more complex part. Okay, open up the SolidWorks. So when I first open it up, it's gonna look like this, right? So I made these two parts over weekend just to demonstrate you guys. You can see these two parts are pulleys and not quite identical. I try to make them identical, but when I'm making the second one, I kind of lost track of what kind of dimensions and the parameters I put in the first one. So please assume these two are identical. And the reason I make two is because I want to show you guys there's always more than one way to model the part you want. It just time consuming or whether or not it's a good practice. All right, let's open up the first one. Okay, first one. You can see this pulley has a V-shaped groove for the belt, and at the center has a bore for the shaft, and it has a tiny little rectangular, it should be a square, but on this half, it looked like a rectangular keyway. Your key gonna be going right here. It's gonna be a square key. And the another half of vacancy should be on your shaft. And these two sides have some cavity due to saving material. Okay. So this is the overview of this pulley. Very simple. And you can see from here, one revolve, one cut extrude. And that's it. This is only two features can build this pulley. Let's open up that another one. This one. Okay, this, assuming a same pulley, definitely with a bigger bore. V-shaped groove. So if I want, I can definitely make this identical, right? 100% if I input the right numbers with dimensions. But look at the left side. Definitely a little bit longer than the first one, right? This is your model tree. First one, extrude. Second one, cut and revolve. And third one, cut, extrude. And another cut, extrude. And another one, cut, extrude. So you may wonder why the features are so different and you're making the same part. It's because of the way you're thinking, right? You make a pulley, you can make the cross-sectional first and revolve it. Or you can make a pancake first and then add in the features like the groove, the bore, the keyway, like one by one by other features. But what is the advantage of being less, being used with less features? So when you try to modify any dimensions with less features, is easier because you open up and added this feature. It shows all the parameters you have designed. But this one only show one because this is how thick you extrude it. And you want to modify others, you have to save, go into another one and edit. This is time consuming if you deal with a very complex part. And also, when you hand over your work to somebody else, like the next person gonna continue your work, when they see so many trees, and they're like, wow, which one is which one? What does this cut revolve do? And he has to click it and say, oh, it made a groove. And this one, oh, it made a keyway. But there are three cut extrude, and they're all representing different feature, right? So it's gonna time consume for them. And this one, plain simple. There only one possible cut extrude is a keyway, and you can spot it right here right away. Okay, let's make these two parts from scratch. I want to show you guys how this software operates. So let's make a new part. All right, we start from scratch, nothing right here. A top plane. Let's try it. So first one, I want to demonstrate you the one with more features because when you're getting to modeling, your thinking would be very simple. After you get more experienced, you know the shortcut and how to do it quickly. So let's go to sketch, draw a circle, and make this circle radius of 5 inch. I'm totally making those numbers up. So you, when in your own practice, use whatever number you like. All right, let's make a pancake first. We have a circle.
Professor, when we draw the circle, do you want us to center it on the front plane?
Doesn't matter. So okay, let me show this. Let me delete this. Okay, when you see the front plane, before you sketch anything, you need to select a reference. Either it's a plane or it's a surface. Right now, we don't have anything, so we have to select a plane, right? And you select the plane, you click the circle, and you see there's a point. What is this up, the up arrow and right arrow? That's your coordinate system. If I exit it, you see there's a coordinate system. This is default coordinate. If you're dealing with a very simple part, you just need one coordinate. But if you're dealing with something like hydraulic parts or whatever things, you might need 2 or 3 different coordinate systems. The reason you're asked about why the circle is at the center of your front plane because the coordinate is right here. I can make it up right here, but you're gonna off the coordinate, and that's gonna reference to something else, right? Just like when you're drawing some mathematical problem, you always want to start with origin, right? It's just a habit. So does that answer your question?
Yeah, thanks.
No problem. So we have our circle right here, and let's make that pancake. Extrude to make things thicker, right? And you can see there is an arrow, that means there's direction. You click it, it flips, right? And it goes, there's even some metric scale right here. Goes how far it is, but we can set it up right here. So it's 1 direction and 2 direction. The first one is your direction 1, and the second one is your direction 2. In this case, we don't need any other directions. you're gonna see the option right here, blind. Blind pretty much is from that reference plane, go up to the direction you want it. And up to a vertex, up to surface, and offset from surface. You're gonna try those one by one. They all represents different the way they want to extrude it. And this time, let's choose the meat plane. The reason we choose meat plane is so that this one, you see, in the middle, there is a line. What does this line represent? That represents a plane we just selected. So your plane gonna sit in right in the middle. And this extrudes from both sides. Okay, let's do 1.5 thickness. And be careful if you choose meat plane. 1.5 inch 1.5 inch thickness means 3-inch thickness in total because it expands from to both sides, right? 1.5 to left, 1.5 to right.
Professor, are we always going to work in standard system when we're modeling for your class? My SolidWorks is set to metric.
Oh, you can change it right here. So setting option, you go unit. Here's the unit system. You choose this.
Okay. So
Yeah.
you want us to always work in IPS?
I hope so, because that's gonna really help you in future. Because
Okay.
are you planning to work in US?
Yeah.
Yes, we're the only nation that use English unit for modeling everything.
That sucks.
I know, right? I have to complain so many times when I receive foreign drawings because I have to manually convert everything. So just keep in mind, convert everything. If you have like 1000 millimeter, is 24.4.
Does SolidWorks like automatically convert for you?
No, it doesn't. Because when you receive the drawing, it's a piece of paper. How
Oh.
does how does that automatically convert to you? Different companies won't allow to send origin files. You're getting legal issue. All you can see is prints. Okay. So now you can see the right plane right in the center. Top plane do the same thing, and your front plane, which we initially referenced that, right in the middle. All right. If you choose blind, this top plane gonna be sitting right on this surface, the highlighted surface. All right. This time, let's choose top plane to sketch. Let's sketch it, and you see this is not the orientation I wanted. So let's go top plane, right click, normal to, and now you see is way better, right? So initially, let's make some center lines. All right, let's tilt this. You can hold Alt and then go hold Alt and hold your middle button of your mouse and rotate it anyhow. Let's make another center line because we're gonna use those as reference. And let's make the V-shaped groove. Okay. Alrighty. 2 blue lines formed. Why is blue? Are you guys really lost? Like from which part? Because we just began.
I'm not sure how to move the camera looking at the part.
Oh,
It's middle mouse button.
yeah, middle
Oh,
mouse
it is.
button.
Oh,
It's the scroll wheel thing.
Oh,
Yeah.
okay, thanks.
Yeah. Sorry, I forgot that.
Yeah, it's different in Autodesk, so.
Yeah, absolutely. This is one thing, probably the only one thing the Creo and the SolidWorks share the same. Yeah, I kind of hate this because in Creo, if I hold Alt and I orientate the subject, it goes like 0 to 45 degree to 90 degree and 135, such and such like that. And this one, I have to manually adjust to merely 90 degrees. So, I don't know. I don't know why SolidWorks has been like this. All right, anyway, It's blue lines because they are not fully defined. We can move it. You see, you drag it, it moves. And now let's define those. Smart dimension, 2 center line. Let's make this 1. Oh, no. Wait. Oh, my bad. I thought we add a 3-inch thickness. Sorry, my bad. It's still 1.5-inch thickness. Okay.
You added 3 total, right? But only 1.5 on your side.
Yeah. No. So the total from this point to this point is 1.5.
Oh, gotcha. Okay.
Yeah. I'm sorry. I delivered the wrong information at 5 minutes ago. Okay. Now see it turns black because it's fully defined. Try to move it. It won't let you. Let me quit this first. Try to move it. It won't let you. Okay. Now let's use mirror entities. Have these 2 lines selected for mirror and mirror about our center line. And that automatically creates another side. If it's symmetric, it's very powerful, save you a lot of time. And you don't have to do any dimensions at the right-hand side because it's already fully defined. Okay, for those of you who got lost, don't worry about it. Let's go through this first, and then we're gonna dismiss the class. And people who has problem, stay after. I'm more than happy to do it again for you, or do it again and again until you get it. All right, let's close this section. I don't know why SolidWorks doesn't have a projection button right here. If I have the projection, I just project this line, and I don't have to manually draw the line. I couldn't find it. I tried to type it right here, and it doesn't show up. Anybody know where it is?
Oh, it's called convert entities. It's on Sketch, and then to your right, convert entities. That right? No, right there to your left. Convert entities. No, to your left a little bit.
Okay.
So you just click the line that your thing is supposed to be on. You click that, and then you click convert entities. Yeah, and then it converts it.
Okay, thank
very
you so
buggy,
much.
though.
Yeah, it is. Why it called convert entity? I'm not trying
It
to
doesn't
convert
work
anything.
half the time.
Oh my.
It sometimes crashes your model too.
Oh
so
my.
It's great. I love it.
Yeah, thank you so much. You helped me a lot. Okay, so we have a closed region, and now we're ready to do the revolve cut. And revolve center, this the center line we just created. And now you can see we already have a preview of how the groove is gonna be, right? This highlighted section gonna be removed. Voila. We have our groove, and it finally looked like some pulley. Yes, if you want to go to tomorrow lecture, you could do that. Just email me, I'll give you the link. All right, what's the next? Next, let's make the bore. And this time, I want to select this surface as my reference instead of those planes. Let's sketch. All right. We still want a better view. Here we go. Let's set it up 2. And extrude cut. Let's do extrude cut, but this time let's try something different. Up to a surface. How about that? And which surface? This one. And here we have a bore. And what about the material remove? Let's still do a revolve cut. All right, let's select this surface, circle. Want it to be 3.75. I don't want to endanger any thickness of my wall right there. Let's say this and cut it. Definitely want to cut it inwards and pointing inwards. That's good. So let's do a quarter. And you can view it from here. Quarter is good. Still too fast? Or still too fat? 0.125. Oh, don't worry. After class, I'll make sure you guys all get this. I'll walk you through step by step. All right, don't worry about it. Just try to catch up as much as you can from this point. All right, we have our extrude cut and it's only on one side. What's a quicker way to make it on the other side? Mirror. Right?
Mirror.
Yes, let's do a mirror. Let's do a mirror of this. And, oh, sorry. Wow. Oh.
Would you be able to like manually do it instead of doing like mirror? Like
yeah, you could. That's gonna generate another feature. So instead of 5, you're gonna have 6 features, right? Oh, this one. And the feature to mirror, we want this feature. And now see is out of place, right? Oh, the mirror face and plane, my bad. We want it to on the front plane. Yes, here we go. Yeah. So the mirror face or plane is the axis you want to be, you want to go respect to. And the feature, you choose the feature you just created. And it shows right here. And from the preview, you can see they're pretty much identical. So now we have 2 sides of remove material. And let's break the sharp edge because, you know, these edge are definitely, when you're holding the pulley, it definitely has potential to cut you. And we won't break that. And let's do a fillet. Oh. Okay, you select this edge that you want to break with and hold control and select this edge. So now you can see 2 edges are being selected and you just need to choose a fillet size. Let's do a quarter. So you can see from the preview, it should make a round, right? And you want to do a chamfer? Do a chamfer. Chamfer normally is cheaper than fillet. And the company prefer that. But anyway, we're just a demonstration, right? Okay, what's the last thing? The keyway, right? How to make a keyway? Normally, we can just draw a rectangle shape right here, extrude cut it, very simple. But since it's a keyway, we want to make some special reference to it. So in future, if they want to swap to a bigger key, we can always adjust the height and we know how to adjust accordingly. And also, the way you model always related to how you're gonna draw. For example, every dimension I input is gonna show up in your drawing. And do you still remember the first step? I put a radius of 5. So in the drawing, you're gonna show up this part has a radius of 5. You want to convert that into diametric, then there's gonna be an extra step, convert radius to diametric. But however, if you make this circle with a diameter 10, on your drawing, it's just gonna show up straight with diameter of 10. Okay, the reason I'm saying this is because when I set up a keyway right here, the keyway's dimension is not just, you know, the keyway is a 1/4 inch depth, something like that. No, like the machinist won't know from how far from this circle, from the edge of this bore to the top of the keyway. They won't know that. They always respect to either the bottom of the part right here to here, like give it a distance of like 2.95 or something, or from the center. And in order to achieve that, let's make another datum. But another datum offset it by this plane. Let's do 0.25. Oh, sorry, 2.25. 2.25 seems fair. We're making this number up. And remember, this part, this 2.25 going to show up on your drawing is representing the distance from this plane to the top of the keyway. So once we have this plane, let's draw it. Let's sketch a rectangle. Oh, sorry, before that, let's make a center line because you know the keyway is, right? And since we already have a center line, let's do a center rectangle. My bad. We shouldn't do center rectangle. I'm sorry. Let's just do line. Making sure it exactly touch this part right here. I don't want to do center rectangle is because I don't want that rectangle extrude out right here. I want to just barely touching this line and close out right here. And let's mirror this one. Okay. Okay, so pretty much we draw our rectangle. Okay. Let's make this 0.5. Again, those numbers totally make up. There's no, the keyway is not just 0.5. Okay, so all black, fully defined. We have a closed region. Let's go make the extrude cut. And this time, since the keyway should be always through, let's make it through both, so that from the preview you can see it's not only through this part of the disc, the pulley, also cut through the entire thickness of the pulley. And here we go. We have a pulley. Any questions before I move to next part? And 1, 2, 3, 4, 5 features. No questions? Okay.
I do.
Yeah.
Would you dock points for unnecessary features? Like if we had...
No, I won't. So pretty much, the only 2 times I'm gonna see your model is from two projects, right? The first one, you're gonna send the model anyway because without the model, I can't open the drawing. I'm not gonna grade on your model on the first project. Every 100% is on drawing, so how you model it doesn't matter. I model it at your most comfortable way. And the second one is assembly. I'm not gonna look into individual model unless your assembly goes something wrong. If you just simply, I open it up, it's fall apart, I'm probably gonna look individual model to see what's causing that. But I'm not gonna duck any points based on the way you model. You wanna model the complicated way, go ahead. You wanna model the way being more efficient, which I'm gonna show next, please do.
Okay, thank you.
Cool. Any more questions before I move to the next pulley? Okay, let's go. I'll say this interface is killing me. Okay, so from this one, let's do another way how to model the pulley, the same pulley. So let's choose a different plane. All right, well, it doesn't really matter which plane I choose. Let's just choose a random one, kind of normal to this. And the first thing, let's think, how to model this more efficiently. If you want to make it revolve, including all the features, what kind of part you want to draw first in 2D? The cross section, right? Because the cross section gonna rotate it with the center axis, and you have your pulley right there. So let's do 2 center lines just to make the reference, and later better for us to revolve. Okay. And what is the cross section of a pulley? I'll say let's draw a rectangle first. What the hell is this line probably? All right, look fairly. It look fairly alike the pulley. So from the top to the center axis, this is gonna be the radius of your pulley. I'm gonna put 5. And from this bottom line to the center axis, it's gonna be the bore. And if you still remember the bore we put, I think it's 2, right? So the pulley radius of 5, the bore radius of 2, and that's where we put it. And now let's make the groove. So again, make 2 lines right here and dimension those. I don't know, 1 probably. And click here, click the center line. Here we go. 0.5.
How did you do the 5-inch and the 2-inch again?
Okay. Let's quit this first. So you click the smart dimension.
Oh, okay. Like how did you?
Okay, you
Okay.
left click this line, and then left click this line, give you the 5.
Oh, okay.
Yeah.
I meant
And-
how did you get your rectangle to look like that?
I'm not sure I'm getting a
did you-
question.
So is that from where it's measuring the 5? Is that the origin, or is it just a measurement of?
Oh no, these dimensions help you to shape your rectangle. Do you remember,
Okay.
like if you recall, this rectangle look a lot of slimmer when I first made it, right? And now
Yeah.
it look kind of shorter because I defined the 5 and the 2 as is 2 boundaries.
Oh, okay.
Yeah. So the smart dimension is help you to shape the initial geometry into the final shape you want.
Oh, okay.
And that includes lines, rectangle, circle, echelon form, whatever, pentagon, yeah, that kind of stuff. Okay. Now you see another. What? Okay, another dimension. What is this? 125, probably. Okay, now you see the V groove. This one, 2 black lines, good, fully defined. However, these 2 are still blue. That means we need to add another set of dimension at least to define those. Thickness, let's put 1.5. Same to that. And you see here, something wrong is here. This line extruded. Why? Because we defined this line before we made the change to this rectangle. So thinking the computer, they receive the order saying, okay, you define this line to be certain length, and then you change something else. You change something else, am I gonna change this line? No, because I don't receive any order to change this line, okay? And in this case, this is not gonna affect us, but in your case, when you make your own model, they probably will. And let's mirror this, just like the uh, just like the previous one. And now you see here has two dots. I'll say two vertex. What does that mean? That means you have a line overlapped. So that line initially, this is one line, this is your second line, so you have something overlap. And do you think when we revolve this, that overlapping is it gonna stop you? Yes, they're gonna stop you. They're gonna give you an error message because it's not like a continuously closed region when you revolve. So what do we do? Let's get rid of the lines. So trim entities. So now see, it's power trim, so you can remove anything. You just hold your mouse. Oh, it's gone, right? You can only see one line right here and the other line is gone. And the corner is to connect two lines and help them merge. You click left click this one and left click this one, it automatically connects them together. And the other are, you're fun to try it. So now, yes.
Or black lines and not blue lines.
Sorry, can you repeat?
Can you only use the trim feature for only black lines? So lines that are already defined?
Nope, nope. You can use it to any line you like. Okay. It seems like you always use it during black line because at the final stage, you already fully define everything and you just want to trim something unnecessary. That's already a final stage, right? That's why you see probably you only use the trim to black lines. Right. Okay. And let's draw that material remove. You still remember the material remove? We extrude cut it, we mirror image it, and we put a fillet or a chamfer on the edge to break the sharp edge, right? That's too much of trouble. Let's just do it right here. And we can just make the chamfer exactly like this. And you can make the fillet by using the splines, you know, like that. Up to you. And we can dimension this 0.25 and this to here 3.5, this to the center 3.75. Okay, all black, fully defined, and let's mirror this set to there. Okay, now you see we have a very basic shape of the cross section, right? If we revolve at this point, do you think we're gonna make it? Probably not, because again, in order to revolve, you need a continuously closed region. The rectangle itself is already a closed region, and we draw a bunch of features inside of it. So it'll get confused. Are we gonna generate a disk or are we gonna generate a pulley? So let's trim the unnecessary line that, oh God, that we don't want. Okay, you can hold your mouse button and just go across and keep holding. And here we go, it's all gone. You can even use this trim button to erase everything that you just drawed, as long as it's by sketch. All right, we done our trim. Everything look fully defined. And let's go revolve. And let's choose the center line. And here we go. We have our pulley in one simple feature with a bunch of dimensioning. We have the pulley. And the only thing left is a keyway. And the keyway, I always make the keyway like that because if you want to identify the keyway depth, you can simply add this plane and this is your value right here. You want to make it 2.75. You have a really deep keyway. So you don't have to go into the keyway feature, because in my company, we make keyways to our pump, and the keyway has a lot more features than this. We don't want to mess up the keyway feature, and sometimes one part can has multiple keyways, and we always use datum to adjust the keyway depth. So I hope that will help you in the future. That's why this is my practice to make a keyway, and you're welcome to find out your own way that make you comfortable.
Professor,
Yes.
could you do that again?
Edit the datum, or edit,
yeah.
or make a keyway.
Well, just the process of making that the little puck.
Wait, you mean the keyway?
Yeah.
Okay. So choose a plane that goes through the center, and make another plane. And depends which direction you want. Oh my God, that arrow cannot be clicked. In Creo, I click the arrow, it automatically flips it. Oh, what? Or did I click the wrong thing?
Is there an undo button or no?
I believe so. Try Control Z.
Yeah, Control Z's undo.
The undo button is on the upper left.
Upper left. Normally it should be right
Oh,
here. Right?
I don't have.
Oh, this one.
Yeah,
this
that one. Yeah.
Yeah, that one. Yeah. Sorry about that. I'm still getting familiar with the interface. Oh, God. Okay, 2.25. You set it with this direction. You want to flip to another direction, flip offset. This is so unhuman. Okay, anyway. You generate this datum, and now let's draw the rectangle. And from sketch, you just draw, let's draw a center line, because we're gonna mirror it, right? Because the keyway is always symmetrical. So click this line and click this edge. 2 clicks give you a line. And now you mirror this line about the center line. Now you have 2 lines. And now you can click, 1 click, 2 click, 1 click, 2 click. We have our rectangle. And let's dimension it. Okay, the reason I mirrored it is because when I dimension from this line to this line, if I put 0.5, you see it shrinks from both sides. It goes symmetrically. If I do want to be 1, it expands simultaneously. But if you just manually draw 1 line here, 1 line here, without mirror, you dimension this to 1, and you're gonna find very awkward that this line is not gonna move. Only this line moves. So your keyway is like shifting right here. It's not symmetric about the center axis. That's why I use a mirror image. Oh, should be 0.5. Do you guys okay with that? All right, with this, let's extrude cut it. And extrude cut it, we say through all, both, so we don't have to worry about dual directions. This goes left and right, because it's at both. If you just through all, sorry, like blind, you see only go one side. And you have to punch in a magnitude, how far you want to go. Wait, through all does the same thing. And through all both. Oh my God. Whatever, just stick with through all both then.
Through all both makes it so it goes from both sides of the plane. If you do through all one, it only goes infinitely from one side. If you do both, it goes from both sides of the plane.
Okay, I see. Oh, thank you. Yeah, because we started at this surface, right? Is it through
Yeah, yeah.
all? Yeah, it goes to
Through- yeah,
almost
through
right.
all, yeah.
Yeah. Okay, I get it. My God. More headache. All right. So here we go. We have our second pulley. The two identical pulley by different way to model. And I hope you guys understand stuff, but if you don't, I'm gonna definitely go over that. So any questions? If you have no questions, I think, and also you think you're comfortable with this, you're free to go. Our class ends right here. You have more questions, want me to do things again, please stay, and I'm definitely gonna do it again. And I'm gonna stop recording. How can I stop recording? Oh.